Welcome to Pavements, webinars for the pavement community. My name is Andrew Braham, and today we're going to talk about quantifying pavement preservation in Arkansas. This is based off a class project that Dr. Sadie Casillas taught, CVEG 4863, Sustainability in Civil Engineering, and the class project revolved around quantifying pavement preservation in Arkansas. And you can see a picture of Sadie with her husband and her beautiful daughter on the right. Sadie obtained her Bachelor's of Science in Civil Engineering from 2013, her Master's in 2015, and her doctorate in 2020, all from the University of Arkansas in Civil Engineering. She can be found on LinkedIn by searching Sadie Casillas, and this class project is actually an extension of a previous Pavenar exploring the influence of preservation, maintenance, and rehabilitation on Arkansas's highway network. And that previous webinar placed one single treatment on the entire network, and we do not advocate doing that, so Sadie developed a class project exploring using a suite of treatments on Arkansas's highway network in order to obtain pavement preservation in Arkansas. So let's start with some pavement preservation definitions from the Federal Highway Administration. Their definition includes terms such as planned work that is performed to improve and sustain the condition of transportation facility and that the facility is good repair. The Transportation Research Board, or TRB, defines pavement preservation as the proactive use of cost-effective treatments that extends lives of the existing pavement, and you want to have the optimal pavement condition and application timing. And then finally, the National Center for Pavement Preservation, NCPP, defines pavement preservation as a network-level, long-term strategy that enhances pavement performance. It is an integrated, cost-effective set of practices that extends the pavement life, it improves safety, and it meets the road users' expectations. And there is another Pavenar that you can look at for pavement preservation specifically that can be found on April 16th, 2023. Now, some key terms that we saw on that previous slide were planned, proactive, and optimal, improving, sustaining, extending the pavement condition and pavement life, and cost-effective treatments. But you can see all of these are qualifications, not quantifications. Now, there is a quantification out there called remaining service life, or RSL, and this is one of my favorite units. And there is the calculation for remaining service life to the right, but a way to describe remaining service life is by using its units lane mile years. So let's pretend your network has one lane mile, so it's 12 feet wide by 5280 feet long. If you don't do anything to that road, if you let that one lane mile sit, for 1 year you have a 1 lane mile year loss, which means your network is decreasing in quality. Now let's say you have that 1 lane mile, but you put some sort of 4-year preservation, 4-year maintenance, or 4-year rehabilitation treatment on there. After 1 year, you actually have a 3 lane mile year gain. So the point of this is if you're improving your network by placing treatments on the road that extend the life, in theory, your remaining service life would be going up across your entire network. And so what Dr. Casillas did is she simplified the 2018 ARDOT network. We simplified it into freeways, multi-lane highways, and 2-lane highways. We also found the average traffic on each of these highway types. And you can see this is a very, very typical phenomena where we have very few lane miles of freeways, but that is where the vast majority of the traffic is. And you can see we have a lot of 2-lane highways in the state of Arkansas with relatively little traffic. But in a way to try and normalize that, we can use vehicle miles traveled, or VMT. And you can see this phenomena, this unit, in somewhat normalizes both the length and the traffic. And it kind of weights both length and traffic in order to get an idea of where your vehicles are on the roads. Now what we did is we took ARDOT's $237 million 2018 budget and we established the budget as a percentage of VMT. Right now, the majority of money is spent on the freeways and multi-lane highways, and quite a small amount compared especially to the lane miles is spent on two-lane highways. But by using VMT as our guide, we can kind of normalize and take both the length and the traffic of each of these highway types. Now, ARDOT sent us, I believe, 7 different highway types. So of course there were assumptions to reduce that down to 3. For a class project, 3 highway types is much better than 7, because after a couple it's just kind of rinse and repeat. And also we needed to make some simplifications for lane mile length and traffic, because obviously the traffic is not the same on every single 2-lane highway. But there were some assumptions, and this is what we came up with. And more importantly, we developed 2 more quantifications for pavement preservation. So one of the quantifications was existing service life, or ESL, and this represents the amount of time pavements have been in service. And what you do is you multiply the age of the pavement in each PCI category by the length and network. So for example, PCI A, we made the assumption that the year range is 0 to 12, so a newly built road will stay in the PCI range for the first 12 years. So we used an average age of 6 years. And on freeways, Arkansas had 1,166 lane miles of freeway in a PCI A condition. So you multiply that by 6 and you get just under 7,000 lane mile years for your ESL. So you can see here the 5 different PCI grades, A, B, C, D, and F, the approximate year ranges that these occur in, and then the average life within those year ranges, the associated freeway length, so the lane miles of freeway in those conditions, and then the corresponding freeway ESL. Now I do want to note, ARDOT no longer uses the PCI grading system. They're now on the MAP 21 system, but this is a nice tool to have available because we used the website roadresource.org. So this is how you calculate the ESL. It's basically that average life times the length in the network at that condition. And so we have our freeway ESL here, and we could do the same for our multi-lane and our 2-lane. And just like the traffic and length, you can see the freeway has the highest number of PCI A and B, and the 2-lane has the highest ESL of PCI D and F by far. It really is not even close. Now the second quantification is what we call the length of time to reach true pavement preservation, or T-Pres. And we put true in quotes here because this is a new unit that we had developed. So T-Pres is the existing service life divided by the remaining service life. And we define true pavement preservation as your entire network being in PCI A and B, so essentially in very good or good condition. And this is very important, you have 0 net lane mile years RSL. So previously I had mentioned a positive RSL is good because that means your network overall is becoming in a better condition. Our premise, however, is that if your entire network is already in a good condition, you don't need to raise it, so you don't need a positive RSL. You don't want it to go down, so you don't want a negative RSL. So if you can get your entire network in a PCI A and B condition, your RSL can be 0 and you will be content. So how did we optimize the network for this project? So first we selected the pavement treatments, and we used the typical ARDOT pavement treatments. By far the most common treatments are chip seals, minor mill and fills, and full depth remove and replace. So what we did is we applied chip seals to PCI A and PCI B roads. We applied the minor mill and fill to PCI C and PCI D roads, and then we did the full depth remove and replace to PCI F roads. Then what we did is we utilized the RSL calculator, the remaining service life calculator, on roadresource.org. If you have not been to roadresource.org, I encourage you to finish watching this video and then immediately go to roadresource.org. It is a fantastic website. But what we did is we treated the same percentage of PCI D and F roads. That means we did spend time on those roads in bad condition that need to be brought up. But this is very important. We treated 100% of the PCI A roads. So we kept the roads that are in good condition in good condition. And this is absolutely critical for this to succeed. And then we simply maximize the remaining service life within ARDOT's budget. Based on that, we determined the T-Pres and the preservation budget. So we calculated the T-Pres for each highway segment using the remaining service life. We ensured that the PCI, D, and F roads could be treated within T-Pres. And then we determined the preservation budget to keep the roads at PCIA. And then, very importantly, we shifted the remaining budget to the next highway segment. So we went over a lot of details here, and I encourage you to take a look at the full paper because it walks you through these very clearly. But this is a very important sequence to go through in order to get the final results. So using ARDOT's current treatments, these are the conventional treatments. Again, we put chip seals on PCI A and B, we put minor mill and fill on PCI C and D, and we put full depth reclamation on PCI F. You can see this is the original budgets for freeway lane miles treated. And note how we are taking care of our roads in good condition. We are putting chip seals down on the PCI A and B roads. We are taking care of those roads that are in good condition. And then we did the same thing for both multi-lane and two-lane treatments. So based on this, we found out that we would need to spend these are in millions of dollars, but we need to spend approximately $1.9 million on our PCA A and B roads for chip seals, just under $1 million for our original budget, and just about $400 million for our original budget on two-lane roads. And these were all budgeted proportionally by the vehicle miles traveled. Then what we did is, after we took care of our roads in good condition, after our freeways were in PCI A and B, we took the remaining money and shifted it down to both the multi-lane, and then once the multi-lane was in PCI A and B, we shifted the budget down to two lanes, and you can see that the budget significantly increases after we shift that money down. So we had our original budget. Once the freeways were in PCI A and B, we kept those in A and B, and we shifted all the remaining budget down to multi-lane. We got that in PCI A and B, and then we shifted the original budget down to two-lane. And we'll go through an example of this in the upcoming slide. So we found that for using the conventional treatments, it would take 2.21 years to get to T-Pres. That means that it would take 2.21 years to get our freeway in PCI A and B condition using $94 million a year. Now, the adjusted budget was also $94 million, but then once we got into PCI A and B, we would only spend $8.9 million a year on the roadway. So once your true pavement preservation was reached, you can reduce the budget significantly. And this is because we're only treating PCI A and B roads. We're only placing chip seals down on our freeways. And what we can do is we can shift that savings down to multi-lane highways. So how did we do that? We adjusted the budget. So you can see originally it would take 13.8 years to get to PCI A and B and multi-lane highways. But after you shift your excess budget down, it only takes 3.97 years. And so let's walk through this adjusted budget. The first thing you do is you take that $94.2 million and you subtract the $8.9 million, and then you add that difference on to the $48.8 million, and that gives you $134.1 million. So 94 minus 8 plus 48 gives you about $134 million of your new budget. Now, as I mentioned, because you add to your budget, you go from $48.8 million to $134.1 million, you can take care of a lot more roads a lot more quickly, and you decrease your T-Pres. And then you have, once you're in a PCI A and B with your multi-lane, and your freeways are already sitting in PCI A and B, once your multi-lane's in PCI A and B, it only takes $11.1 million, so you can shift all your budget down to two lanes. So then you can increase your budget from $93.5 million for two lanes to $216.5 million for two lanes. Now what's important is, if we just kept our original budget, our $93.5 million, it is not possible using the conventional treatments in order to get to T-Pres with our two-lane highways. And this is what states are facing. They have a lot of two-lane roads that are not in good condition, and the way they currently are taking care of these roads, they literally cannot keep up. It is not possible, and our data shows that. But what our data also shows is that when you adjust the budget, if you get your freeway in PCIA, if you take care of those roads in good condition, in theory, they will not get into the heavier rehabilitation needs. It costs a lot less money to keep a road in good condition. So if we can keep our freeways in good condition and have them stay in good condition, if we can take our multi-lane highways and get them in good condition and have them stay in good condition, we can put all of that money into our two-lane roads. And the good news is within 86 years, our two-lane roads can be in A and B condition. Now, for a total of 92 years to get our entire pavement in good condition, that is a big order, and that is a time scale that people are often not terribly comfortable with. But the beauty of this is with our existing budget, it's actually possible to do. It'll take a long time, but it's possible to do. If we keep our roads that are in good condition, if we keep them in good condition, that will allow us to put more resources to the roads that are not in good condition and bring those networks up to good condition. And the nice thing is after 92 years, in theory, our preservation budget's only $90 million, which means we can actually save $146.6 million a year because our entire network will be in PCI A and B condition, and all we'll be doing is putting chip seals down our entire network. Now, that is not terribly realistic. I don't recommend putting chip seals down on freeways, but these are ARDOT's conventional treatments. This is what they use far and away most commonly. So what we did is in the classroom, Sadie asked the class, they broke into groups and said, you need to optimize your treatments. And so for freeways, the most optimal treatments that were found by harvesting data from the class was rejuvenating fog seals, microsurfacing, minor mill and fill, cold in place recycling, and full depth remove and replace. For multi-lane, it's very similar. You see some scrub seal, a little more CIR. You see some full depth reclamation getting in there. And then for two-lane highways, again, quite similar, rejuvenating fog seals and chip seals, cold in place recycling either with chip seals or hot mix asphalt, and then full depth reclamation with 4 inches of asphalt. Now again, we chose these treatments, these 5 treatments for each of the 3 freeway or highway types by using both data harvested from class and some engineering judgment as well. So there were some that had slightly better performance, but we did use engineering judgment. And again, the paper goes into all these details. And then when we do the optimized approach, you get a very similar table, but you can see it only takes 46 years. Well, first, you can see T-Pres is still not possible with the VMT original budget, but you went from 92 years to just over 46 years to reach T-Pres, and you have even a higher budget savings. So that 92 year was a little scary. 46 years is not that bad. It's still a long way out there, but if you can get all your freeways and multi-lane highways into A and B condition in 5 years and keep those in good condition, people aren't going to mind if you start putting that money toward 2-lane roads, and eventually your entire network will be in an A and B condition. So some conclusions: we defined what we call true pavement preservation, which is your pavement network in good condition, PCI A or B, with the remaining service life of 0 lane mile years. If ARDOT used conventional treatments and the current budgets, we could reach true pavement preservation in 92 years, and we would save $146 million a year at that 92-year mark, but the budget should be allocated proportionally to vehicle miles traveled. Using optimized treatments, ARDOT could reach true pavement preservation in 46 years, and we'd save $155 million. But very, very important here is you need to be proactive in applying treatments to roads in good condition. You need to take care of the roads in good condition. So, went through this very quickly. There are a lot of assumptions we went over, so I encourage you to take a look at the full paper. It's in the Journal of Transportation Engineering, Part B, Pavements, and the link can be found in the description section below. But thank you very much for joining me today, and I hope you have a wonderful day.